Hello, my name is Dawid. I'm tech lead at Vizlib Astrato, and as Gerard said, I would like to talk about micro front-end module federation, but mostly about import maps. So let's start with the theoretical background, maybe, and recap what micro front-end is about. It is an architectural style in which independently deliverable front-end applications are composed into a greater whole. It has some advantages, such as smaller, more maintainable code bases, more scalable organization, and the ability to be upgraded or even rewritten in a more incremental fashion. Wherever there are pros, there are also cons, and so micro frontend can lead to duplication of dependencies, increasing network usage. Also, the dramatic increase in team autonomy can cause fragmentation. By saying that, I mean all the cons of working in silos. Today, I would like to focus on duplication of dependencies and show you how we can achieve it, mitigate it, stuff like that. There's a conflict between independent applications and autonomous teams, and our desire to share some common dependencies between them. We must all agree that there are some things, such as common libraries, global styles, etc., that can and should be shared, even if the idea of sharing comes with its own set of difficulties. This is our product, Astrato. It looks like that. It has some panels like top bar, sidebar, settings panel. It also displays charts. The charts are more or less independent from each other and use our own common visualization library under the hood. So it would be great to share the library across the charts, and thanks to that, save some space, network usage, stuff like that. For the purpose of that presentation, I've prepared a minimalistic application. We have two Angular applications. They are independent from each other. And each of them renders a chart using one of the most popular library for doing that, called chart.js. Later, they are composed into a greater whole, as we said before. Let's look at the bundle size. For the first application, main.js file has around 233 kilobytes. I'm curious, how much does chart.js take of it? Well, without the chart.js being bundled, the app has only 86, or the main.js file has only 86 kilobytes. By doing simple math, we can estimate that by sharing somehow chart.js between those two applications, we can save up to 31% of space. That's huge, that's a lot, and that's definitely worth checking. Of course, as usual in web development, there's a lot of ways how to achieve that. And today I would like to show you one of my favorite. It's called ImportMap, no surprise. But before we go further, I believe we need to first understand the foundation for that functionality. So back in 2009, when Node.js was introduced, later AngularJS, React, etc., JavaScript didn't provide any built-in module functionality. And so the community had to figure out their own solution. This is how CJS has been introduced as the primary way of packaging for Node.js. It loads modules synchronously and requires bundler in order to work in the browsers. Hence, AMD asynchronous module definition came out. It loads modules asynchronously and doesn't require bundler in order to work in browsers. Later, UMD, universal module definition, as the name may suggest, it works for both AMD and CJS. It first checks for AMD, then for CJS, and if both aren't available, it tries to export and import from and to global object. And last but not least, back in 2015, ECMAScript modules, or JavaScript modules, in short ESM, was released to JavaScript as the native module functionality. And since it's built in, it's becoming a global standard. All major JavaScript-based projects are being migrated, such as Node.js, which supports right now both CJS and ESM. Also, since Angular 13, Angular doesn't provide anymore UMD, it only provides ESM. In 2018, 3 years later, Chrome team announced that all major browsers support JavaScript modules. It's cool because since then we can use import-export statements, and it is understandable by the browsers. So all of that creates the foundation for ImportMap. Let's see at the official example from the official documentation. So in the first file at the top of the screen, we have 2 import statements, one for moment, one for Lodash. We already know it is understandable by the browsers, but now we can add another script of type ImportMap, which contains a JSON describing the map. By doing so, we can specify how those import statements should be resolved. In our example application, we say we should resolve the chart.js with the path pointing to the official CDN. So after running the application, we see there's actually no difference. What happened? Well, despite the fact that we specify the import map, Webpack doesn't know about it. So in order to fix it, we need to customize Webpack configuration. And the funny thing is that at the beginning of Angular, it was cool because it was hiding almost whole configuration. It was working automatically. A couple of years later, based on NPM trends, we can roughly estimate that around 15% of all Angular projects use some sort of Webpack customization. Given the Angular popularity, we talk about hundreds of thousands of applications. So in order to do that, I personally like to use custom Webpack from Angular builders because it's deadly simple. And all we need to do is just enhance the default config and specify additional parameter called externals. After running the application, we get a runtime error. So what's going on? This is the output file generated by Webpack. In order to render a chart, we need to create an instance of chart class. The chart class is get from chart_js_ blah, blah, blah. What's that? This is a variable which stores a result of calling Webpack require with an ID 2083. And under that ID, Webpack tries to export something called chart.js, so JS property of chart object. That's wrong, so let's fix it. In order to do that, we need to just add 2 yet another parameters, experiments output module and externals type. What do they change? So we still need to create an instance of chart, we still need to call Webpack require, but this time Webpack tries to export something called _Webpack external blah, 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 blah. What's that? This is a variable which stores a copy of chart.js. And what's cool is that Webpack now uses JavaScript import statement. And as we know, it is understandable by the browser, and ImportMap supports that syntax. Okay. We have apparently a typo. Yes, this is not a valid JSON file. Let's fix it. And we get yet another runtime error. This time cannot read properties of undefined, reading register at render bar chart. It rings the bell. Let's see how bar chart directive looks like. We have our register method. It's called from chart class. Chart is get from chart.js. So apparently there's something wrong with module feather resolution. And here we go. So this is one of the most important thing in terms of ImportMap. It supports only ESM format. It doesn't support CJS, AMD, or UMD. So let's fix it. And here we go. Our app is running again. Let's have a look at the network tab. We have 2 applications, so we expect 2 main JS files. They both have 88 kilobytes each. It suggests that they do not contain chart.js, and chart.js is loaded once, together with its dependencies. What's a little bit worrying me is that it has more than 400 kilobytes. That's strange because at the beginning, we estimated that chart.js takes around 146 kilobytes. So what happened? Well, before it was Webpack which performed tree shaking. Right now, we do not perform any sort of tree shaking. So we load whole library rather than just parts we use. How serious is that problem? That's the question. So from the clean code, we know that we should manage third-party boundaries by having very few places in the code that refer to them. Just to protect our investment and make sure future changes won't be too expensive. So in other words, we should hide a third-party library, or at least the common one, behind an abstraction that we own. Let's do that then. So we are back in our bar chart directive. We switch and start using our own library called custom chart.js. It exposes render bar chart function as well as render line chart, and it looks like that. So we basically moved the implementation from one place to another. We also need to update our import map as well as Webpack configuration. And here we go again. What's cool? Okay, I lost the screen. Okay. What's cool with that approach is that we can very easily do something like that. Something is happening here. Yeah, so 3D gradients, other things that glitter and sparkle, it's really easy. All we need to do is just change the implementation in one single place in our library. So for example, we can switch and start using zinc chart, as simple as that, without touching or affecting anything on the application side. But let's go back to the import map. With that approach, it is on us to make the library available at runtime. It means we need to bundle and probably transpile it. And it means that we can perform tree shaking. I personally like sbuild, so I use it to build the library and eliminate dead code by providing the flag. So now the library has around 183 kilobytes. It's much less than relying on the official copy of chart.js. It's still slightly more than we estimated before, but let's say for our example application, it's good enough. So in the end, we have managed to save around 24% of the overall space. What are the other potential obstacles with ImportMap? For sure, browser support. So Safari proves one more time that it is the new IE and is killing the web. Having said that, there are polyfills available. On the other hand, ImportMap contains a couple of very interesting features, such as, for example, scoping. So while it is not so great idea to use multiple versions of the same library within an app, in micro frontend, it should be at least technically possible. Scoping is very useful with bigger refactorings or upgrades. ImportMap supports also dynamic generation. So if you need to resolve imports differently depending on, for instance, a feature flag, it's completely possible. But what I personally like the most is its simplicity. It takes less than 15 minutes to explain the whole concept and the implementation. And we really want to keep things simple. By talking about micro frontend, we talk about complex web applications. And complex web applications, complex systems, exhibit unexpected behavior, produce complicated responses to problems, operate most of the time in failure mode. So we really so things can go weird, go wrong, and we really need tools easy to understand and debug with. So when an accident happens, we do not need to rely on gut feeling, make shotgun debugging, or voodoo programming. We know exactly how things work. So let's just summarize. ImportMap supports only ESM, has no default Safari support, there are polyfills available, and has no default, doesn't perform by default tree shaking. On the other hand, Module Federation supports CJS, AMD, UMD, and ESM, has default support, and performs tree shaking by default. But what's really a killer feature from my perspective is the fact that ImportMap is built in. We already said that we want to keep apps independent and teams autonomous. It means that teams are allowed or should be allowed to use any sort of bundler, if any. Meanwhile, module federation is just a feature of Webpack, right? Try to compose into a greater whole, multi-version, multi-framework, multi-bundler application. It's a nightmare. With import maps, it's just simpler, in my opinion. Remember, everything in software is a trade-off. So we should never shoot for the best architecture, but rather for the least worst architecture. That's even reflected in Vizlib and Astrato career ladder. So an architect should be able to design the least worst architecture, taking into account trade-offs. And speaking about Vizlib and Astrato, we are hiring, so please check out our careers page. Having said that, thank you very much. That was a pleasure. Let's connect on LinkedIn. You can also subscribe to my newsletter, and you can find source code for the presentation on my GitHub. Thank you.